If your API bill is higher than expected, your agent keeps forgetting things that you already told it, or you're not getting the performance you feel like you should based on all of the demos you're seeing online, then this is the video that you need to watch. What I'm going to do today is go through a deep dive of the OpenClaw architecture. I'm going to explain memory, tools, performance, caching, saving cost, and give you a ton of examples of really quick fixes that you can make that will dramatically improve your OpenClaw instance. This allows you to go from a base instance with a little configuration to all of the best settings installed in probably just under 1 hour. I would highly recommend watching the entire thing. However, if you do want to skip forward to any sections, they'll all be available from the video player down below. With that in mind, I also created this really sleek guide that kind of goes over everything that we're going to talk about. If you want to access this guide, I'll leave a link to it in the description. And if you're interested in having a professional AI team set up your OpenClaw for you and implement it in your business, I am running something like that. Again, I'll leave a link below in case you're interested. Anyways, with that said, let's get into it. And the first thing I need to do is warn you about security. We are currently dealing with the bleeding edge of technology, right? OpenClaw is relatively new. It's open source. There have already been a ton of security vulnerabilities, so you need to be very careful when you set this up. At minimum, do not set this up on your main computer. Do not give it access to all of your primary accounts, and ensure that however you do set it up, it's sandboxed and in an isolated environment where it can't make a ton of mistakes that would be critical to you or your business. So connect it to a separate Google account, run it in the cloud on a virtual private server in a secure environment, use a trusted host that can deploy it for you so that you know that you are safe from the beginning, and you're not, for example, leaving yourself vulnerable or leaking a bunch of your company data. So I do always recommend running this on a virtual private server as opposed to your own hardware, even if you have your own dedicated machine. The reason for that is that a virtual private server is actually going to be more cost effective. It can be significantly cheaper even if you span it out over a couple of years. You have the ability to scale it up if needed. You have things like automatic backup, and it's running in a cloud environment in some kind of data center, which in most cases is more secure than the airport. So for example, if someone stole your Mac Mini off your desk, they all of a sudden have access to all of your data, your OpenClaw instance, all of that. That's not going to happen with a virtual private server. If a fire happens in your apartment, you lose everything. Again, it's not going to happen in a data center. And if it does, they have disaster recovery. So even myself, having the highest end hardware you can imagine, I run all of my OpenClaw instances on virtual private servers. If you already have one set up, great. If not, what I would recommend is using Hostinger to create one. I have a long-term partnership with them. It's what I've been using since the very beginning when OpenClaw came out, and they have one-click deploy options, which make it pretty much instant to deploy it in a secure environment where it starts as low as just $9 per month. So what I'm going to do is just deploy a fresh OpenClaw instance right now so that everything that I do in this video is starting from scratch and I don't assume any knowledge, and then we'll get into all of the different topics. And if you're looking for this particular page here, it's just hostinger.com/techwithtim. I'll leave a link to it in the description. What I'm going to do is just select the KVM2 plan, go ahead and press on Launch OpenClaw, and just go through the flow here and deploy a new instance. Now, like I said, this is a one-click deploy. It actually uses Docker to deploy it in an isolated environment, so it's just secure by default effectively when you're running it. And what you can do here, if you're deploying this, is you can use the code TechWithTim, which will give you an additional 10% off if you have a new account and you select a plan that is beyond 12 months. You can use 12 months, 24 months, whatever. And then if you want, you can use their ready-to-use AI credits as well as their instant web scraping. However, I'm going to disable those because I'm going to use my own API key, and that's typically what I recommend. All right, so I'm going to go ahead and press on continue here. We'll just go through the provisioning stage, and then I'm going to show you the fresh instance so we can start doing all of the config, walking through the file system, etc. Okay, so the server is set up now and we can start using it. If you're using Hostinger, it should have brought you to a page that looks something like this after first prompting you to enter some API keys. So it would have asked you to enter like an Anthropic API key or an OpenAI API key. You only need to put one of those. Just make sure you have at least one. In my case, I'm using Anthropic/Claude, so this will work out of the box. Now, what we're going to be looking for if we're going to launch this for the first time is we're going to go to Docker Manager, Projects, and then we're going to copy the gateway token, and we're going to press this Open button. Now, because this is already pre-installed, it's very easy. You can just paste the gateway token here in the field, and then press Login, and it's going to open up the OpenClaw control. Okay, now I already just did this quickly to test that it was working, but you can just type something like hello or hey, and you can see that it's all good. We can start chatting with it and that it's functioning. Okay, so this is great. OpenClaw is here, it's set up. However, what we want to do now is we want to get SSH access to the machine so that we can start viewing the file system, which is extremely important, and making the changes that I'm going to recommend. Okay, now in order to do this, we can go to the Overview tab here from Hostinger, and we can find these two fields. So the root access field, as well as the root password field. Now the first thing we're going to do is we're just going to change the root password because we need to set it, because by default it's not set to anything. So I'm just going to generate a random password. So go change, generate, and just copy something here and copy it to my clipboard so that I have it saved. Okay. Now, if you're not using Hostinger, that's totally fine. Just make sure you know the credentials to sign into your virtual private server. So whatever the user is, the password, and then the IP address, which is right here. Okay, so we could go here to the terminal, which you may have seen in other tutorials, and go SSH and copy this command and type in the password. The issue with this is it's not very visual and it's very difficult to modify the files. So what I'm going to recommend that you do is use a visual editor, something like Visual Studio Code, to actually remote control or SSH into your machine, but be able to view the files like they were on your own computer. This is kind of a pro tip here that I'm surprised more people don't talk about, but what you can do is just go to the internet, just search VS Code. This is a free code editor. It's open source. It's maintained by Microsoft, and you can download it. So I've just downloaded for Mac. I already have it downloaded, and then open it up on your computer. Okay, you don't need to be a technical wizard to do this. Just literally download the software and open it. From here, accept any of the stuff it asks you for. And then what we're going to do is go to this extensions pane. So extensions looks like this, kind of like 3 blocks, almost like a puzzle piece. And what we're going to do is type remote SSH. We're just going to install an extension which will allow us to remote into a virtual private server and view it in what's called a code editor. That's what we're in right now. So we're going to go here to remote SSH and we're going to install it. Okay. Now, once it's installed, so just press install. It should reload the thing here. What we can do is hit Control-Shift-P. We can type remote. And by the way, I'll show you how to open this again in a second, but this is the command palette that I'm in. And then find this remote SSH connect to host. Now to find this, because I know I went fast there, you can use the keyboard shortcut Command-Shift-P or Control-Shift-P, depending on the operating system that you're using, and it should open this up. If for some reason that's not working, you can use the file menu and go view and then command palette and it will open it up. Again, you search remote and then find SSH connect to host. From here, we're just going to put in the host that's here. So root at, don't include the SSH part, just include your username at and then the IP address. So I'm going to say root at, and then I'm just going to go back and find it a few times because I don't want to lose the password that's on my clipboard. So I have 187.77. I think it's 17, let's see, or .110.171. Okay, 110.171. Okay, I'm gonna go ahead and press on enter, and that's gonna open up a new window for me. From here, I can just hit enter for the password, and it should authenticate me and bring me into a remote environment in the code editor where I can view the full file system of OpenClaw, which is really essential to be able to actually make the changes and work with this in like just a better setting. Okay, so from here it's kind of loading. What we can do is we can press this little icon here, which looks like 2 files, which is the File Explorer, and we can press Open Folder. From here, if you're working with a hosting or virtual private server with the OpenClaw deploy, you can type /docker, okay? And then when you do that, and you put another slash, you're gonna see some containers. We're looking for the OpenClaw container. So we're just gonna find that. We're gonna go data, and then we're going to find the folder .openclaw. Now this is the folder that you're looking for. It's called .openclaw. Based on how you set up OpenClaw, it's going to be in a different location. It's usually in your user's home folder. Okay, in this case, because it's in Docker, it's in a different location, but again, usually in the user's home folder. So we're going to go ahead and open that up, and we're going to press trust folder and continue, and then go yes, I trust the authors. Now when that opens, you should see in this left sidebar, which you can toggle with Control-B or Command-B, that we have a bunch of different folders and files, okay, identity, workspace, all of this kind of stuff. So what I'm going to show you now is what all of these files mean and then how you can do some advanced configuration to make the OpenClaw better. So the first thing that I want to get into here is the memory architecture. Now memory is really critical to OpenClaw because it should learn and get better over time if it's set up correctly. Now when we talk about memory, we have a few different things to go through. We have, for example, markdown files, which are on our disk. Let me just zoom in a little bit. We have the context window, which is things that get added into the model as you communicate with it. We have a compaction engine, which we'll look at later. And then we have vector memory search, which is a more efficient way to search long-term memory that's not loaded by default. Now, the key principle here is that if this is not on the disk, OpenClaw will not remember it, and I'm going to explain why. So the way that OpenClaw works is that it has an LLM, which is kind of at the forefront of all of the decision making, and that's really the AI, right? So Claude, GPT models, Gemini model, a local model, doesn't matter. That's the LLM, which is the brain of the operation. Now, this LLM was trained on trillions of pieces of information by some of the best companies in the world, Anthropic, OpenAI, etc. It doesn't know anything about you. And also, it doesn't remember anything about you. It just sits there, it works the same for everyone, and the thing that changes how it behaves is the information that you feed it. So that's why you hear about context windows and memory and all of these things, because effectively all an LLM does is predict an action or a chain of text. You give it some prompt, it gives you something out. So when we talk about memory, that doesn't mean the LLM is actually remembering these things. Effectively what we're doing is we're kind of cleverly saving information on our own computer and just feeding it to the LLM when it needs that data so it can make an accurate decision. So that's why understanding this architecture is so important. The LLM doesn't change. You use the same base LLM and nothing changes about it. What changes is what you give it, which also makes it very powerful because you can kind of engineer how the LLM behaves based on the information you pass it. Okay. So let's keep going here, and I want to talk about the two memory models that OpenClaw has by default, and then later we'll look at specific changes that we can make to it. Now we have kind of two places that OpenClaw stores memory. The first is this memory.md file. Now this is a long-term persistent memory that gets loaded at the beginning of every session or initialization of OpenClaw. This is a place where it stores long-term facts, things that it always needs access to, and it's typically going to be a slim, smaller file that is not touched very often. Next, we have a memory folder which stores daily memory logs. I'm going to show you what it looks like in 1 second, but effectively what it will do is it will track what happened in the previous days, and then OpenClaw by default will read the last 2 days of memory. So what that means, and this is an important thing that you need to understand, and we'll look at it in the file menu in a second, is that if I tell OpenClaw to do something 30, or let's say 72 hours ago, and it didn't store it in its long-term memory, by default, it will not know that or load that. So if I told it, hey, my favorite food is pasta, 3 days ago, and it didn't store that in its long-term memory, if I ask it now, what's my favorite food, it will not know because it will not have access to that information because it only loads the last 2 days of short-term memory from this memory folder, so the logs of what's happened in the previous days, and the long-term memory. So what you need to know if you're architecting OpenClaw is to tell it to save things to long-term memory when important and to check what's in that long-term memory file because that's always going to be loaded. Now later we'll look at an optimization that lets OpenClaw search through memory more efficiently because it can search previous memory to find information, but by default it doesn't do that very well. Okay, so like I said, the model does not persist memory and waits, right? Every session starts from scratch, and effectively the agent reads this memory information, okay? Now also, large memory files means more input tokens, which cost you more money, okay? So there's always a trade-off. How much do you want it to know versus how much do you not want it to know? And that is, again, something that we'll talk about in a second. So sorry, I want to go back to my VS Code. So if we have a look in our workspace, we'll see all these markdown files that by default are created. And workspace is where a lot of the stuff is happening that you need to pay attention to. Now, if we look, we have this memory.md file, which by default will be empty. This is the long-term memory file I'm talking about. Now, as we start chatting with OpenClaw, so let's do a sample conversation here. Hey, OpenClaw, I want you to save in long-term memory that my name is Tim, and then just create the short-term memory file for today and kind of summarize what's gone on so far just so I can demo it and have a look at it. Okay, so we'll just tell it to do that, and we'll keep going back to my other window because I'm used to doing that. We'll just wait a second, but we should see that this memory file gets updated when we tell OpenClaw to do that. And if we have a look in a second, yes, you can see memory here, long-term memory is created. We should get a new folder that stores the short-term memory. And you can see we have this memory folder that gets created in the workspace. It doesn't have anything inside of it yet, but this is the folder I'm talking about. And then there you go, we get the date, right? And it has this short-term memory. So those are the directories that I'm talking about. And every day it should automatically save to this so that you have the short-term memory updated. And then again, this memory file gets updated as needed. Now, actually, if you look through some of these other files, I'm not going to go through all of them because that's not what this video is focused on. You'll see that you have like a user.md file. Again, more information that's loaded to the model. Tools, right? Soul.md, this is kind of how the model behaves. You've probably seen this before if you've played around with OpenClaw. And then you have this agents.md file. I would recommend that you read this because it explains how the memory is crafted, where it says, read this today plus yesterday for recent context, right? Previous 2 days. And then if you're in the main session, then direct chat with your human and also read memory.md. So memory.md, this long-term persistent memory, is only read in the main session, so the one where you're effectively architecting OpenClaw, not any of the sub-sessions or something from a different area. I don't know exactly how to explain it. And then again, you can see it explains how the memory works. Your long-term memory, write it down, memory is limited, all of this kind of stuff. So I would recommend reading this file because it explains the philosophy, and you can change this if you want, but that's by default how the memory model kind of operates, right? Okay, so let's, again, we're gonna get into optimizations, by the way, for this in a second, but I want you to understand why before we make the change. Now, the next thing to talk about is context window, okay? Now, context window is effectively how much money you end up spending with these companies like Anthropic, which just recently added like 6 billion in annual run rate because of how much people don't understand this and are just literally ripping through tokens unnecessarily. Now, you can see that I've kind of created this chart here where effectively there's all these different things that get loaded into the LLM, like I talked about, anytime you start chatting with it. Now, the first is the system prompt. Now, this is something that's fixed. You can't really adjust this very much, and it doesn't make a massive impact, but this is like all of the core instructions on how to operate that you really do need. The next can be bootstrap files. So these are semi-fixed. Sometimes you need them, sometimes you don't need them. Again, what do you read on startup to have the information you need to continue for the rest of the chat? Next, we have things like memory files. Again, this is variable depending on how much information that you're storing. We then have skills. So if you're familiar with OpenClaw skills, these are markdown files that you can give OpenClaw that it can save long-term, that it can read through to determine how to do something. Now, skill files, if you add hundreds of them, can actually really bloat the context, which means anytime you're chatting with the model, it's looking at all 200 of the skills that you have and seeing if it should use any of them. That's additional information that sometimes you don't actually need and can cause actually inaccuracies with the model. Then conversation history, like it says here, #1 cost driver. So if I'm chatting with the model for a really long time, by default, it saves everything that happened previously in the chat in the conversation. So if I'm chatting with it for 30 minutes and I don't make a new session or I don't compact that down, which we'll look at, you'll see that it ends up costing a lot on every subsequent, message send that you do with your model. And then we have tool outputs. So again, this is something that will happen in the session history, where if you call a tool and it does something, that information, so the result of that tool call gets passed into the LLM, which can grow extremely large and cost you a ton of money over time. And then last, compaction summary. We'll talk about compaction in a minute, but you can compact the session down when it starts getting too large and then add that in the context. So what you want to understand is that what is my LLM actually reading? What information does it have access to? How does that affect my cost? And how does that affect the performance of the model? So as you can see, we have these list of commands that allow us to view different information about our context. Okay, so for example, we have like context detail, usage fold, usage tokens, and status. Let's just start with maybe status and just see what this looks like. So if we type /status, you can see, let me zoom in a little bit. It tells us, hey, it's OpenClaw. This is the model that we're using, 4.6. Here's the key. Here's the tokens currently in and out. Here's the cache hit rate. Here's the context, session, all of this kind of stuff. Okay, so it's important or useful to be able to look at that. Next, we can look at the amount of usage we have with various tokens. So if I go /usage tokens here, again, it can tell you the exact token usage and the percentage of the context window that is being used. And then if we go, so let's actually just go context list here. And when we do that, it should give us a more detailed list of what's being loaded in. This is super useful to have a look at every now and then. Okay, so you can see here, it gives us a detailed list of all of the different number of tokens for all of the context that's being loaded into our prompt. So this is super useful to have a look at. You can see memory, right? Okay, bootstrap, heartbeat, user, identity, tool, soul, agents, all of that kind of stuff, and the number of tokens that are loaded in and whatnot. And notice that inside of memory.md, and if we go here and we look at memory.md, we have some context, but it actually hasn't loaded it. The reason why it hasn't loaded it is because we're not in a new session yet. So if I type /new, which creates a new session for you, which is something useful if you just want to start a new conversation from something like the control panel here, then what we can type is / and what was that command that we already had? That was usage full or something. No, slash context list, okay? We should see now that the memory has some content because it would have loaded. So you can see memory, 56 tokens, 221 characters, loaded, okay? So anyways, just wanted to show that to you. Cool, and then there's a few other ones. We have slash context detail as well, which I believe gives us even more detail than the list, where you can see exactly how many parameters and literally everything is being used. And a good habit is to ask the model, hey, run these commands and give me kind of a token audit to see where I'm using a lot of tokens. So anyways, it's useful to know this. Ignore this bootstrap config thing. We'll look at that later. For now, I want to go over to compaction and flush. Now it's being cut off a little bit in the HTML. That's fine. Just go back here. But let me start talking about how this works. So now we move on to compaction and something called memory flush, which you may not have heard of. Now, compaction is built into pretty much all of these like orchestrated platforms where when the session gets too large, so you've been chatting with it too much, it compacts, which means essentially removes everything previously and summarizes it into a small number of tokens and passes that back into the session. Now, this works well and you want compaction enabled because it's going to save a lot of tokens for you in terms of if you have a really big session. However, when it does that, what can happen is you can lose a lot of information that's important. So a feature that I recommend enabling in your OpenClaw is something called memory flush. Now, it looks like this, where effectively what's going to happen is rather than just clearing all of the data, whenever you hit a certain token threshold, OpenClaw will automatically flush whatever is in your session into long-term memory if needed. So effectively the prompt is, write lasting notes to whatever, a reply, no reply, if nothing. So what we're saying is, hey, okay, we're getting to a point where we're about to compact all of this and lose all of the information. Before we lose it, what we want to do is store any durable memory. So anything that we've talked about, we want to automatically store that, even if we didn't explicitly tell the model to do that, so we end up remembering a lot more things, right? So this is memory flush. So the way that we enable this is pretty easy. We're going to go to our openclaw.json file. This is where all of the config typically is. All right, so from OpenClaw, the way that we enable this is we're going to have to kind of write it in. We're going to go to find agents. We're going to look for defaults, and then just anywhere in the defaults block here, we can add the compaction field. So we're going to say compaction, okay, like this. We're going to create the JSON object, and then unfortunately in this guide that I created, it didn't give me proper JSON, so we're just going to copy a few of these things. So we're going to add this reserve token floor. Now what reserve token floor will do is it's going to automatically keep 20,000 tokens when we do a compaction. So rather than us just clearing everything and just summarizing and starting from scratch, we keep at least 20K so that we have more context. Next, we're going to add memory flush. So again, I'm just going to copy this in, and then I'm going to add all of the different quotes that we need because this is unquoted the way that this guide kind of generated. So I just need double quotes around all of my fields here so that it can be valid JSON. Unfortunately, VS Code can just fix that for me. And you can see now that we have enabled soft token threshold, system prompt, session nearing completion. You get the idea. So this will enable the memory flush for us, which is just going to give us a better performance. So now that we've done that, what we can do is we can just go back to OpenClaw here, and we can just tell it /new. And then I'm just going to ask it if the memory flush is enabled. If not, we might just need to restart the gateway. So I'm going to say, is memory flush enabled? And let's see if it is. Okay, and you can see that it just told us, yes, memory flush is enabled. Here's the configuration, enabled soft token threshold. You get the idea. Okay, so the next thing I want to talk about here is vector memory search. Now, by default in OpenClaw, we have these markdown files that you saw, right? And what that means is that if we want to search for memory, we have to actually just look for keywords or like relevance ranking in those documents. Now, that's fine, and OpenClaw will do this by default where it will search through the memory, but the memory search strategy that it uses is not optimal and can lead to you having a bunch of information that's not relevant. So what we want to do is we want to enable something called vector memory search. Vector memory means that first, what we'll do is we'll create a vector database that's relatively small that runs on our local computer, and we'll create something called an embedding. An embedding is kind of a numeric representation of our memory that can be searched a lot more efficiently than just standard text-based content. So what we can do is we can set it up so that we use a different memory backend that will automatically vectorize the memories for us. And then when we need to search for the memories, it will use the vector search, which is a lot faster and more accurate to pull in the relevant context. I'm not going to go through all of the details, but essentially what we can do here is we can enable this config right here where we enable the QMD backend. So in terms of enabling the QMD backend here, you can obviously just adjust the config with something like this. However, what I would suggest is instead going to the OpenClaw documentation. I'll link this page in the description for the QMD backend, which is experimental, and just copying this example that it has right here because it has pretty much all of this stuff. And then going here to your OpenClaw and just pasting it in and say enable QMD backend, and it should be able to just enable this by default for you, or if not, at least tell you what it is you need to do to enable it. Okay, so after you tell it that, it's probably going to restart the gateway, which might disconnect you and reconnect you. And you can see now it's enabled and we're good to go. Okay, so the next thing to move on to here now is to talk about MCP, and I'm going to show you something called Composio. Now, when you start using a lot of tools in, OpenClaw here, you start to bloat the system a lot and you start to really confuse the model because you give it access to so many things and it just tries to go and use all of them. And also, like we talked about before, you bloat like kind of the system prompt because you're adding so many different configs that the model constantly needs to read through. Now, you also start getting a lot of issues if you try to connect with something like Google, for example, where like you create a Google tool, you have like an API key for Google or something, or a credential from Google, and you end up storing that just in plain text on your server, which is not a good idea, which is a security vulnerability, etc., etc. So if you've been working with OpenClaw for a while, you've probably realized that tools might work at the beginning and then they start breaking. You give it a credential, it works, then the credential disappears, you lose it, or worst case, it's actually just sitting on the computer in a plain text file that anyone could potentially read, or that could be read through someone doing a prompt injection with your AI model. So overall, tools and connections are fundamental to OpenClaw. You need them, but the way in which you connect them can cause a lot of problems and lead to some instability and also additional costs and stuff that we'll talk about in a second. So what I would recommend if you're serious about actually running this instance and you're gonna have more than just 2 or 3 tools is to use a dedicated platform that handles all of this for you called Composio. Now, I partnered with them for this video, however, they are free to use and I use them in all of my OpenClaw instances, so I was happy to discuss them. And that's because they just provide a better tool interface for your model. I'm going to show you how it works in 1 second, but effectively what you do is you connect OpenClaw to an MCP server or plugin. You can choose which way you want to do it, which connects to something called Composio. Composio then has a huge list of tools. It's like thousands of different tools that you can connect to, where you go to their platform, you authenticate directly with Composio in a secured environment, and then you just give a single API token or like header, which we'll talk about in a second, to your OpenClaw instance. So anytime it needs a tool, what it does is says, hey, I need a tool, let me go to Composio. It says, hey, Composio, what tools do you have available? And it actually searches for a tool rather than reading all of the tool list. So let me give you an example, right? If I have 100 tools on my OpenClaw and I need those all in the system prompt in order to find them, I have to look at 100 different tools, and that's 100 times whatever the tool value or token size is, right? That describes what the tool is. Whereas if we switch to a model like this, Composio exposes like 4 or 5 tools, one of which is search tools. So rather than me having to see 100 of them, I see 5. I use the search tool feature, which then goes to Composio, where I'm now no longer using an LLM, searches for the correct tool and passes it back to me or gives me a refined list. So now I only need to look at maybe 10% of the tools or 20% of the tools in my system prompt or in whatever the prompt is that's being sent to the LLM, which drastically reduces my token cost, especially because that gets multiplied for every single tool call. Composio then executes the tool on its own platform, parses the API response, authenticates for us, and passes the result back to OpenClaw so that it's only getting the data that it needs and it's not getting bloated with a bunch of additional information. Anyways, I'm not trying to oversell it to you, just technically how it works is superior to the default way of just making tools yourself in OpenClaw, and whether you use this or something else, a third-party provider that handles all of that for you is a lot better, right? So what I'm gonna do here is I'm just gonna go and start setting it up. So essentially what you can do is just go to the Composio website. Also, you leave a link in the description in case you wanna get started with it. You can go to composio.dev, just press on like start building today, and then just sign up for a free account. Now by default on the free account, let's just go here to billings. You can see you get 20,000 tool calls per month, which for almost all of you is gonna be enough. And then of course, if you're going and doing a ton of different tools, you can pay more to use this, or you can switch to something else if you don't like it. Again, it's free, you don't need a credit card, you can just start using it. All right, so once you've made an account on Composio, what we're actually gonna do is we're just gonna change the URL here to say dashboard, because this is the new page that we need to go to, so dashboard.composio.dev. Now from the dashboard, you may need to make a new workspace here. So what I'm gonna do is just go new, and I'll just make another one. So I'm just gonna call this demo, like here, and go create organization. Okay, and from this page, what we can do is we can connect Composio to OpenClaw. It actually gives us a guide right here on exactly how to do that. So I'm gonna press connect to OpenClaw, and it's gonna give us a prompt that we can just pass directly to OpenClaw to connect it. So what I'm gonna do is just paste in this prompt here where it says add a new MCP server called Composio with the transport type HTTP, use this URL, and then use the xconsumer API key like so. So we're gonna go ahead and press enter. While we do that, I'm gonna go back to Composio, and you can see there is a ton of different tools here. I believe there's like actually thousands of integrations that we can add. So now we can integrate all of the tools and connect them from one place. So what I'm gonna do is go to, for example, GitHub, and let's connect that one for now. And then once we do that, we'll have a tool list here inside of this dashboard, and we can configure what tools we want to give access to OpenClaw. You can see there's 866 tools for GitHub. It's now loaded all of them because we've authenticated, and we can go here and connect a bunch of other integrations as well if we want to. And again, if you use the Google integrations, it's all handled. You won't get timeout errors like you would otherwise, sorry. So now it's all connected, or it should be after it's doing this here. So let's give it a second and see if it's able to find the tool that we added. Okay, so we can see it had to do a little bit of setup here. It had to install this MCP Porter skill, but now it's all good. And then I can tell it something like, what GitHub repos have I recently created? Because I'm connected to GitHub, and I'll say use Composio to find that, just so that it has a chance. And you'll see now that it should be able to locate those skills and be good to go. So we'll let that run. While that runs, let's keep going with the rest of the flow. And then we'll go back and just check to make sure that that works. All right, so again, I was just explaining, why do we want to use the MCP server thing here over using the custom tools? I went through a bunch of it. You can read this slide if you want, but generally there's a much leaner schema in terms of how the tool works, what it is, the parameters, all of that kind of stuff when you use a provider like this, which just saves you money in terms of loading the skills right into the prompt. You have just-in-time tool discovery, so you discover the tools as they're needed. You don't have to have all of them at once. And then you have this remote workbench, so there's a large API layer that sits between you and the tool, so that you can pull only the necessary information to pass to the LLM, which again gives you a lot of additional tokens. Then you have all the security benefits, right? So you have all the OAuth stuff, as you can see here, automatically handled, SOC 2 compliance, whatnot, rather than having all of these issues where you can see like 93.5% of tokens are wasted before you even start reasoning. You have, for example, Anthropic terms of service is now prohibiting using like subscription tokens. Google is automatically rejecting OAuth refresh tokens that come from OpenClaw, all kinds of issues that are coming up if you don't have something like this. Okay, now let's go back here, and you can see that it has found the most recent repositories by connecting through Composio to GitHub. Cool. Okay, so now let's keep going. Next thing I want to talk about is prompt caching, okay? Now I have an entire video that talks about all of this, which I'll put on screen right now, but I highly recommend that you enable prompt caching. Now prompt caching will effectively save all of the tokens that are repeatedly being sent over to a model provider like Anthropic, like OpenAI, so that you don't get charged for them on subsequent calls. Now, the reason why this is important is because a lot of times the tokens that you're submitting are the same. Like you're submitting the same system prompt, the same tool list, the same, memory, right? Like a lot of those things are not changing a lot, but if you don't have caching enabled, then you're getting charged every single time. So to give you an idea here, a normal input token is just 1 times whatever the price of that token is for the model. However, if you have cache writing enabled, when you're writing to the cache, it's going to be 1.25 times as expensive. So more expensive to write to the cache, but when you read from the cache, it's 90% cheaper. It's 10% cache read. So that means that if I have 1 million tokens that I write into the cache, yes, it costs me 1.25 million tokens to write it, but then any time I read it, it only costs me like 100,000 tokens or 10%. So if I read more than 2 or 3 times from the cache, I immediately get that cost savings back. So you almost always want to enable this. For different models, you can change it, but you can see kind of how it works just with this description. And then what you can do is you can also warm the cache. So what will happen is the cache will invalidate itself by default after 1 hour. There is something that you can add to your heartbeat where every 55 minutes you effectively just run the heartbeat, which will spin up the agent so that it does one task. If it does that, that will just automatically warm the cache on something like OpenAI, on something like Claude, so the cache stays alive for longer, saving you more tokens. You don't have to warm the cache, you can invalidate it if you want, but this is something that's pretty common that a lot of people are implementing. They just enable this setting directly in OpenClaw.json. Okay, next thing, cost impact matrix. So I want to just quickly go over kind of how this works. Okay, so let's start going through a few of the important ones here. Okay, same thing, memory.md, we talked about this. The larger it is, obviously the more expensive it gets. System prompts, bootstrap, that's kind of fixed. There's not too many changes you can make there. Daily logs, I won't get into this too much, but the more that you can avoid having all kinds of tool calls and random stuff in the logs, the better, because that's going to save you money, because these logs will sometimes be read by OpenClaw depending on how it's performing. Next, conversation history. Again, #1 cost driver. That's why we added that compaction and the memory flushing, so we automatically compact that and make sure that if the session gets too large, we're resetting that. So use those commands that I showed you previously to see how many tokens am I at? Should I reset the session? Should I start fresh? So that you don't have all of this stuff bloating the context. Tool output and history, like we talked about, can cost you a lot of tokens, especially over time when you're doing a ton of tool calls. I mean, you can see like, look how many tool calls are occurring right here when it's trying to run something, right? Whereas now that we added the Composio GitHub thing, it just called 3 tools to get us the result, where normally it would have had to call a lot more in order to generate that. Okay, let's keep going. We have compaction summary. Again, really good. We keep that in. Memory flush. Just costs 1 turn, but then saves you a ton of information. And then embedding calls, you can do this with like an OpenAI model or a Claude model, but usually it can be done locally for free. And then MCP tools and schemas. So again, if you just have all the tools or skills built into your own computer, then you have to load all of them every single time. Whereas if you outsource them to something like MCP, you have a much thinner schema, which will save you money. Okay, cool. So optimization strategies first, session hygiene, right? So reset when you're done, /new/compact. These are 2 commands that you can run. So for example, if we go /compact here, just give it a second and it automatically compacts the context. And you can see that the window will now decrease and we're at 0% context because we just compacted it. Next one, cap the context window. So you can actually change the size of the context window. So this will be when it automatically compacts. If you want, you can move it from usually what the default is of 200,000 with some of these big models now 1 million down to a smaller amount, so you don't need to remember to manually compact or to do the /new. Next, tune the bootstrap size. Again, we don't really need to do this. It doesn't make a massive difference, but you can add this into your config. Disable unused skill, again, super important. Remove any skills or disable the ones you're not using so they don't bloat the system prompt every single time you're running, or use an MCP server so that you get those better prompts. And then sub-agent spawning, so rather than having the main agent complete every single task, if you need something specific to be done that's a small delegated task, you can tell it, hey, spawn a sub-agent to do this. When it spawns a sub-agent, it starts with fresh context, and then you can just tell it to do something like this so it gets only the necessary information. Okay, and then just quickly config cheat sheet. So like here's a few things that you can add directly to the config. Again, like I mentioned, that will enable some of those things. Command cheat sheet, here you go, right? So you can check how to do some of those things. And then the mental model, you can read this if you want, but I'm not gonna go through it. So anyways, guys, that is this video. I know that covered a lot of stuff. It was long, it was detailed, maybe it's boring in certain parts, but I want it to be as informative as possible so I can explain to you exactly how OpenClaw works and you understand the mental model behind what goes into the performance, what goes into the cost, and how you can fine tune it to get a better result. Again, if you want help setting up your own OpenClaw and automating business operations, feel free to click that link down below and my partner and I will reach out to you and we can see if we'd be a good fit. Anyways, guys, thanks very much for watching, and I'll see you in the next one.